Hi, welcome to another video of thematic lectures. Today, I'm now discussing a question from edXL GCSE UK syllabus, June 2022, question number 14. So here, there is a fraction given. Express this fraction in the partial fraction form. So that is the first question. So I'll just note down this question here. Express 3 over 2x minus 1 times x plus 1 in the partial fraction form. Well, you can see here in the denominator especially, this denominator is a product of two linear factors. So if it is a product of two linear factors, what is the rule in partial fraction? We must write it as in this form: a over 2x minus 1 plus b over x plus 1. Correct? Now, we just take the LCM of our right hand side and you just add these two fractions. So if you're adding these two fractions, we will get a times x plus 1 plus b times 2x minus 1 divided by 2x minus 1 times x plus 1. And that is exactly equal to our left hand side, 3 over 2x minus 1 times x plus 1. So what I did, I just cross multiplied a times x plus 1 plus b times 2x minus 1 divided by 2x minus 1 times x plus 1. Now from both sides, we can cancel the common denominator. What we will get? 3 is equal to a times x plus 1 plus b times 2x minus 1. Now, our aim is to find these two constants. So here I'm just substituting some values to eliminate the other unknowns. Like for example, in this case, I'm just putting x as -1. So what happens? 3 is equal to a times -1 plus 1 plus b times 2 times -1 minus 1. So 3 is going to be equal to 0 because -1 plus 1 is 0. 0 times a is 0 plus 2 times -1 is -2 minus 2 minus 1 is -3b. So 3 is equal to -3b, or b is going to be 3 over -3, and that is -1. Clear? Similarly, you should find the value of a. Once again, we will write that equation. 3 is going to be a times x plus 1 plus b times 2x minus 1. So here now, I'm just putting x as 0. So what happens? 3 is equal to a times 0 plus 1 plus b. We already got b is equal to -1 times 2 times 0 minus 1. So 3 is a minus into minus, it is going to be positive 1. You bring this 1 to this side, a is 3 minus 1, that is 2. Therefore, the partial fraction of 3 over 2x minus 1 times x plus 1 is 2 over 2x minus 1 minus 1 over x plus 1. And that is our answer. Clear? So that is the answer for the A part of question number 14. Now, go to the second part. When chemical A and chemical B are mixed, oxygen is produced. A scientist mixed these two chemicals and measured the total volume of oxygen produced over a period of time. The total volume of oxygen V meter cube T hours after the chemicals were mixed is modeled by the differential equation. dV over dt is 3V by 2t minus 1 times t plus 1, where V is greater than or equal to 0 t is greater than or equal to k, where k is a constant. Given that exactly 2 hours after the chemicals were mixed, a total volume of 3 meter cube of oxygen had been produced. Solve the differential equation to show that V is going to be 3 times 2t minus 1 over t plus 1. So the derivative is given as dv over dt. dv over dt is given as 3 divided by 2t minus 1 times t plus 1. Now our aim is to find an expression for volume. There is also one empty condition given. What is that? When t is 2 hours, the volume is 3. We will keep aside this. So here we will first of all separate the variables because we need to solve the differential equation. So cross multiply it. So what happens? Here 1v is also there. 3v upon 2t minus 1 by t plus 1. So what we should do, you bring this dt at the same time, you bring this v to this denominator side. dv over v is 3 dt over 2t minus 1 times t plus 1. Now, if you want to find an expression for volume, we should integrate both sides. The integral dv by v is ln v. There is no doubt in it. Integral of 3 dt by 2t minus 1 into t plus 1. See, in the a part, we have already rewritten this fraction. That means 3 over 2x minus 1 times x plus 1. We already we calculated the partial fraction of this as 2 over 2x minus 1 minus 1 over x plus 1. Here the same scenario, but only one thing is different. That is, instead of x, it is just t. So we should, replace that 3 over 2t minus 1 by t plus 1. We can rewrite it as 2 over 2t minus 1 minus 1 over t plus 1 times dt. Now you can separately integrate it. So ln v is equal to, because integral of 1 over ax plus b dx is what? It is ln of ax plus b by a. So the same scenario works here. 2 ln over 2t minus 1 by the coefficient of variable t, that is 2, minus this is ln of t plus 1. So after integration, we should also keep the constant of integration. So now you can see here, both left hand side and right hand side, all these terms are in terms of length. So anyway, we need to add a constant. So I'm just adding a logarithmic constant to this to synchronize with these terms. So I'm just putting ln c here. 2 got cancelled. What we will get? Ln v as ln of 2t minus 1 minus ln of t plus 1 plus ln c. Now there is a property in ln. So ln a plus ln b is ln of ab. Similarly, ln a minus ln b means it is ln a over b. Correct. So I can use the same thing. So ln v is equal to, here it is minus and then it is added with the ln c, right? So this we can write it as ln of 2t minus 1 by t plus 1 times c. So we got an expression. What is our expression we got? Ln v is equal to ln of 2t minus 1 by t plus 1, and it is being multiplied with the c, right? So if I'm cancelling ln from both sides by taking e to the power of on both sides, what happens? Ln got cancels. So what we will get? V is equal to 2t minus 1 times c by over t plus 1. But there is one problem. What is that? C is one unknown thing. So how will you find this value C? So if you want to find the value of C, you can use this end condition. When t is equal to 2, v is equal to 3. So plug this. V is equal to 2 times 2. I mean, v is actually 3, right? Because when v is, when t is 2, v is 3. So 3 is equal to 2 times 2 minus 1 times c by 2 plus 1. So 3 is equal to 2 times 2 is 4. 4 minus 1 is 3. 3 into c by 3. So 3 got cancelled. The c value, that constant, we obtained as 3. Correct? Therefore, we got beautiful equation, and hence we showed it as what we showed. V is equal to 3 times 2t minus 1 by t plus 1. Hence, short. Hope you got it. Now, we'll move to the C part. Is it C part or in C? Yeah, it's C part. So for doing C part, we will be using this additional information. See, the scientists noticed that there was a time delay between the chemicals being mixed and oxygen being produced. There was a limit to the total volume of the oxygen produced. Deduce from the model, because the model is this equation. The time delay give your answer in minutes, and the limit give your answer in meter cube. See, in this, V is actually in meter cube and T is in hours, correct? In this model, V is in meter cube and T is in hours. Okay, so they're saying that we need to find the time delay. So what is the equation for the model? So V is equal to 3 times 2t minus 1 by t plus 1. And in this question itself, they have provided a clue that t must be greater than or equal to k. So that means for all values of t, this model is not actually valid. See, for example, if we are putting t as 0 here, so 0 seconds, what is the volume we will get? 3 times 2 multiplied by 0 minus 1 by 0 plus 1. So we will get what? 3 times negative 1 by 1. So we are getting negative 3 meter cube. See, that will not make any sense because volume itself is not generating. So now the question is, from when onwards this, from after what time onwards this volume is generating? See, so volume, so we need to find the time at which the volume is generating. So that means volume should be greater than or equal to 0. Correct. So when this is going to happen, we will just equate the equation of the volume. So 3 times 2t minus 1 by t plus 1 should be greater than or equal to 0. So if you are cross multiplying, what happens? 3 times 2t minus 1 should be greater than or equal to 0, or 2t minus 1 should be greater than or equal to 0 by 3 means again 0, or 2t should be greater than or equal to 1, or t should be greater than or equal to 1 by 2. So that means this model is valid, or the volume is only generating after half an hour. Correct. So t must be what? Half hours. But our answer should be in minutes. So that is half into 1 hour means 60 minutes. So it is what? 30 minutes. So only after 30 minutes, the volume of oxygen is producing. Clear? Then in the second question, this volume has what? A limit. So what is the equation for volume? 3 times 2t minus 1 by t plus 1, correct? So we know that when time proceeds or time increases, the volume must increase. But for a very large value of time, so we'll see, for example, say when t is equal to 10 hours. So what is the volume we will be getting? Because we need to find the limit, because it will reach a maximum value of volume formation. Let's see, for example, if t is equal to 10, what is the value we'll get? 3 times 2 times 10 minus 1 divided by 10 plus 1. So that is 2 times 10 is 20, 20 minus 1, 19. So 3 times 19 over 11. What is that value? 3 times, you can also do along with me. 3 times, I'm also taking calculator, 3 times 19 over 11. So we will get, see, we will get it as 5.19, 5.18 meter cube. Now, as time proceeds, for example, when it reaches to a value like, for example, say 100 hours, sorry, so T 100 hours. So what happens if T is reaching 100 hours? What happens? Volume becomes 3 times 2 times 100 minus 1 divided by 100 plus 1. So plug this 2 multiplied by 100 minus 1, that is 199 divided by 101, then multiplied it with the 3. So it will reach 5.97 or 5.91 meter cube. Then when whatever be the value of T, like, a greater value, like for example, 1000 or 10,000. So if it is taking these values, we will be just less than or equal to what? 6 meter cube, because maximum limit is 6, because see, it reaches to 5.97. Then you can do it as an exercise, like you can just substitute T as 200, 300, 400. Whatever be the case, the value is nearer to 6. It's not crossing 6. So what is the maximum value of volume we will be getting? The answer is 6. So that is the answer for this question. So that's all about this question number 14. Thank you very much.